So we have two new rules to find a derivative that we're going to talk about. So the derivative of a constant is always just 0. So if you have the derivative of any number, it's just 0. And then if we have a sum and difference, so if we had like 2x plus 3, then we would just find the derivative of each term. Okay, and we're going to practice this actually real quick. This should say plus or minus. This works for any terms. Okay, so let's do some examples. So if we have, fix my pen, okay, examples, and we're gonna find the derivative. So if f of x equals 3x cubed minus 2x plus 7, then let's go ahead and find the derivative. So we learned power rule in the last video. So for power rule, we're bringing that exponent up front and then subtracting 1. So we're going to do that for each of these terms. So this one would be 3 times 3 is 9. X to the 3 minus 1 is 2. Get this in here. All right. For this one, our power is 1. So 1 times negative 2 is just negative 2. And 1 minus 1 is 0. So x to the 0 just goes away. That would just be 1. And then this is where we have a constant. So the derivative of 7 is 0. So I'm just going to leave that off. So that would be the derivative. Okay, let's do another. F of x equals 8x cubed minus 2x squared, 3x minus 9. Go ahead and see if you can do this one. So 3 times 8, 24, x squared minus 4x plus 3. And again, the constant is just 0, so we leave that off. So f prime of x would be this equation. All right, sometimes these are not going to look so simple. So let's say we have one where we have, oops, f of x equals x plus 3, x minus 2. So right now, I don't have terms separated out. Right now we have factors. So the first thing we need to do is go ahead and FOIL this whole thing out. So we would have f of x equals x squared minus 2x plus 3x minus 6. And then, of course, combining like terms, x squared plus x minus 6. Now that we have everything separated out into terms, we can solve it the same way we did the previous two. So f prime of x, bring the 2 down, so 2x to the first, plus the derivative of just x, there's like a 1 here. So 1 times 1 is just 1. And then the 6 is a constant, so nothing there. Okay. Let's do one more. If we have f of x equals 8x to the 5th plus 9x to the 4th, 3x cubed plus 2x squared minus x plus 1 all over x squared. So, as you hopefully remember from monomials and stuff way back when, if you have just one term in the denominator, then we can just divide each of the terms in the numerator by x squared. So I'm not going to write that in for all of them, but I'm doing each one of these divided by x squared. So if we rewrite this, 8x to the 5th over x squared would be 8x to the 3rd. 9x to the 4th is now 9x squared. This one would be minus 3x plus 2. Negative x over x squared would be negative 1 over x, and then plus 1 over x squared. If you were paying attention in the last video, we also learned a hint that if you have fractions, then we can just put those to negative exponents. So this would be x to the -1, and this would be x to the -2. And now everything's ready to go to take a derivative. So the derivative would be, and see if you can do it, go ahead and pause it and see if you can do it on your own. We would do 3 times 8, so 24x squared. 9 times 2, 18x to the first. 1 times -3 is just -3x to the 0, which I can leave off. Constant is just 0, so I'm leaving that alone. -1 times the negative is +1x to the -2. And then -2x to the -3. And then to fix this so we don't have negative exponents, I'm just going to move those couple of terms to the denominator. So plus 1 over x squared minus 2 over x cubed. And that's it. So in this video, we learned how to take the derivative of a constant, which is just 0. And we also learned that we could take the derivative of multiple terms. Thanks for watching.